Hello, good afternoon. This is Hemalatha from Laxman Reddy Institute of Technology and Management. I'll be teaching you today about the session types of optical fibers. In the previous classes, we have discussed about optical fiber, then what is numerical aperture, acceptance angle, all those things. We have derived the expressions also. In this class, we'll go for the different types of optical fibers. Based on the three major categories, optical fibers are classified into three categories. Based on the types, optical fibers are of three types. One is based on the type of material, that is, what type of material. I told you optical fiber consists of core, cladding, all those things. So, core or cladding is prepared by using material either glass, fiber, plastic. So, based on the material, we have one type of optical fiber. Second, number of modes. How many number of modes are allowed to pass inside the optical fiber? Based on that one also, optical fiber classification is given. Next, based on the refractive index profile. That is one type of optical fiber classification. You can see material. There are two different types based on the material, glass fibers and plastic fibers. Next, number of modes. Based on the number of modes, we have two: single mode optical fiber, multi-mode optical fiber. Next, last one, refractive index profile. Based on refractive index profile, we have two types of optical fibers. One is step index optical fiber, second one is graded index optical fiber. Okay, so this is how optical fibers are being classified. Next, let us go in detail with respect to one after the other. Based on the type of material, I told you glass and plastic. That is, if the optical fiber is made up of with a mixture of silica glasses and metal oxides, then it is called as a glass fiber. Now, you are manufacturing an optical fiber. In the manufacturing process, if you are using the materials like silica glasses, and metal oxides are combined, then we call that type of optical fiber as glass optical fiber. Example, germanium oxide mixed with silicon dioxide. That is, core is prepared by using this material, whereas cladding is prepared by using silicon oxide. So that type of fiber, we call it as a glass optical fiber. Next, coming to the plastic optical fiber. If the fiber, that is optical fiber, is made up of using plastic, then we call it as a plastic optical fiber. That is, core is prepared, for example, if you take core material is prepared by using polymethyl menthaclarate, and cladding is prepared by copolymer. That type of materials, we call it as plastic fibers. Next, depending on the modes, how many modes are propagating through an optical fiber, they are classified as single mode optical fiber, multi-mode optical fiber. Now, what is a single mode optical fiber? If only one signal is transmitted through an optical fiber, only one signal. We are having an optical fiber. Through that optical fiber, only one signal is transmitted. Then we call that type of optical fiber as single mode optical fiber. Now, in this single mode optical fiber, always the diameter of the cladding will be large when compared with that of the core diameter. In general, what is the thing? In general, always the refractive index of core, that is the cladding diameter, will be less when compared. The refractive index of the core will be greater than the refractive index of the cladding. Here, we are talking it in terms of the diameter of the core and cladding. Always the diameter of the core will be less when compared with that of the cladding. So, thus in case of single mode optical fiber, the optical loss is very much reduced. Why? Because we are transmitting only one signal. So, that signal will automatically pass through the narrow grip which is present for the core. So, that's how the loss is reduced in case of this optical fiber. You can see the structure which is given below. Now, what is the use of this one? Optical fiber, this type of optical fiber, if you allow only one signal to transmit? Because when you allow only one signal to transmit, it has very high bandwidth. Bandwidth will be very, very high because there is no loss of signal, and they are used in high communication systems where signal has to be communicated immediately. Then we use this type of fibers, single mode fibers. Next, coming to multi. As the word itself is giving you multi means many. So if more than one mode is transmitted through optical fiber, then we call it as a multi-mode optical fiber. Many, multi means many, single means only one. Now we are passing the signal through different modes. That is, if here the core diameter is compared very large when compared to single mode optical fiber. Why? Because this, in case of single mode, we are using only one signal, whereas in case of multi-mode, many number of signals has to be passed through the optical fiber. So for that sake, what they are taking is the diameter of the core is large when compared in case with single mode optical fiber. Okay, so the cladding diameter is also larger than the diameter of the single mode optical fiber. So this is the picture of the optical fiber which is shown in this slide. Now, because of less bandwidth, it is very useful in short haul communication systems. Long haul communication systems, we use single mode optical fibers. Short haul communication systems, we use this multi-mode optical fiber. Next, based on, this is there in our syllabus. So based on the refractive index profile. Now, what is this refractive index profile? A refractive index profile is nothing but a graph which is drawn with respect to radial distance versus refractive index. A graph which is plotted with respect to radial distance. That is how the signal is transmitting. What is the distance traveled by the signal? Based on that signal distance, which we are representing it as the letter R, which we call it as a radial distance, versus the refractive index. Because here in the construction of optical fiber, we are using two main things, two main components, core and cladding. So core has one refractive index, let us call it as N1. Cladding has another refractive index N2. So because of the difference in refractive indices, here we are plotting a graph of radial distance versus refractive index. This profile, this graphical representation is called as a refractive index profile. Based on this graphical representation, we are having two types of optical fiber, step index optical fiber and graded index optical fiber. Step index optical fiber, the name itself is telling you step index. Step, for example, I take an optical fiber. Let us see, this is an optical fiber we are having. Okay, now this is the optic axis for this one. The center one, that is inside one, let us call it as a core, and the outside one, let us call it as a cladding. This is having a refractive index of N1, this is having a refractive index of N2. Now we are launching a signal, we are incidenting a signal which is entering from outside, and this is incident at a particular point. And now this signal is allowed to pass into the core medium. This signal is allowed to pass into the core medium. That means this light ray which is coming from the outside material, outside path, this is traveling inside, that is inside the core material. That means as long as the light ray is inside the core medium, as long as the light ray is present inside the core medium, it has a refractive index of N1 only. That means it is maintaining a constant refractive index. When the light ray is inside the core medium, here it is maintaining a constant refractive index, that is N1. Now once the light ray touches this point, as I already told, which is called as a core cladding interface, that is the difference in refractive indices is present at this point. So that's why we are calling it as a core cladding interface. Once the light ray touches this boundary surface, that is core cladding interface, automatically again the light ray gets reflected back into the same medium. This is nothing but the principle of an optical fiber, that is a total internal reflection. So now the light is getting reflected back into the same medium. Now the light ray which is getting reflected back is also present in the core medium only. That means in this also it is maintaining the same refractive index, that is N1. So as how the light ray is present, is traveling only in the core medium, that's why we are saying it as a step index optical fiber. Now if you plot it in terms of this graphical representation, now let us take, this is the refractive index N1. That means the light ray which is traveling, which I am showing it in a bold thing here, this one. So that is nothing but this light ray N1. So it is maintaining constant refractive index. Now this light ray is touching this point. Let us represent this point as this one. Let us represent this point here, this one. Now this one, this is nothing but the change in refractive indices, that is N1 minus N2. Here let us take it as the refractive index N2. Already we are having N1. So refractive index N2. Now again this light ray, when it is touching this point, it is getting reflected back. So now the light ray again passes through the same medium, that is, it is coming back into the core. In the core, it is maintaining the refractive index N1. Now this is again N1. This is how, as the signal is coming out in form of steps, we are calling it as step index optical fiber. As the signal which is traveling inside the optical fiber is coming out in form of steps, we call it as the step index optical fiber. So this is step index optical fiber. Next one, we have graded index optical fiber. Now, what is this graded index optical fiber? If you see the graded index optical fiber, the name itself, graded. Graded means the signal is getting divided into different things. That signal is getting divided into different parts. Now, here let us see how the signal transmission is taking place in case of this multimode optical fiber, that is a graded index optical fiber. Now, graded index optical fiber, it is nothing but, if you take the same optical fiber type, let us take the same optical fiber type, then in case of that one, this is an optical fiber, this is the optic axis, light is incident from outside, it is entering into the core medium. Okay, now here let us show it in terms of the graphical representation where you can follow it easily. Now this is radial distance versus now see, or you take it in terms of this core and cladding surface. Now this is how the light is traveling. This is core. This is core. Now light is passing inside the core medium. Now see, as this is in form of a cylindrical shape, now as the light ray is entering inside the optical fiber, now this is the center point of this cylindrical part. Now, let me show you in a bigger view. No, this is the center point of this cylindrical part. Now light ray is entering incident on this core surface. Now once the light ray is incident on the core surface, now it is traveling inside the core surface. As long as the light ray is traveling inside the core surface, it is maintaining as the distance is increasing. Distance is increasing here. Once the distance is increasing, refractive index is also increasing. Now let us take, this is how the distance is increasing. Refractive index is increasing. Once the light ray has reached the center point, that is the center of this core material, then it is maintaining maximum refractive index. That means once the light ray travels inside the core surface and when it reaches the center point, then it maintains maximum refractive index. Then again, if the light ray travels, then again as the distance is increased, then automatically refractive index gets decreased. Now see, this is how the refractive index gets decreased. That means at the center of the core material, the refractive index is maximum. As long as it travels inside, that is from the starting point, it may increase, and towards later that point, then there is a decrease in the refractive index. So this type of index is called as graded index optical fiber. This type of optical fibers are called as graded index optical fiber. That means here the signal is graded at the center. At the center, maximum refractive index is present, and at the corners, there may be increase in the, as long as the distance increases, there may be increase or there may be decrease in the refractive index takes place. So this type of refractive index profiles are called as graded index optical fibers. Okay, this is how the types of optical fibers are being explained. Now next we have the last topic, that is the losses in optical fiber. Generally, when you see in almost all the places, every time they go on digging the roads, they go on doing some or the other disturbance on the roads. Once you are disturbing the roads, in the sense is nothing but the signal is getting disturbed. How the signal? Because optical fibers are there. Once you dig them, optical fiber automatically damages. Once the optical fiber damages, then automatically the signal gets damaged. That damaging, we call it as a loss in optical fibers. Again, this loss in optical fibers is explained in terms of attenuation process. Now, what is this attenuation process? It is nothing but the ratio of optical power output to the optical power input. P out by Pn, how much amount of power is produced to that of the how much amount of power you are giving, that is defined as the attenuation. And this attenuation is explained by using the letter alpha in the practical part, we tell it as 10 by L log of P out by P in. That is, actually we do this one in terms of experimental part. In the experimental part, in the calculation part, in the part of losses calculation, we will be using this particular formula, that is alpha, which we call it as the attenuation loss. It is defined as the ratio of optical power output from a fiber of length L to the power input. So that we call it as alpha, that is 10 by L log of 10 P in by P out. Not P out, P in by P out. And this power loss is expressed in terms of decibel per meter. This power loss is expressed in terms of decibel per meter. Now, here in the attenuation plays a major role in determining the distance of transmission, the signal transmission, through how much distance it is traveled. Based on the traveling of the distance, we can say how much loss is being obtained inside the optical fiber. Then absorption losses. There are different types of losses: absorption losses, scattering losses, radiative losses. Now, what is absorption? Usually, absorption of light occurs due to imperfections of the atomic structure, such as missing molecules, hydroxyl ions, and the cluster of atoms are missing, which absorbs the atom. Now, for example, you take Earth. When you pour water on that Earth, does it absorb or not? So that is nothing but absorption. So here also, once light is incident on some of the atoms, then automatically the light gets absorbed by those atoms. That property, we call it as the absorption losses are taking place. In the absorption losses, there may be lossage of optic hydroxyl ions, or there may be loss of OH ions also. Next, scattering. Scattering is dependent on wavelength, because as the wavelength changes, automatically the cluster of atoms get disturbed. Many number of atoms are there. Then automatically, if you are changing the wavelength, then the atoms distance may increase, they may expand, or they may compress. So this type will be majorly occurring in optical fibers. Next, radiative losses. This radiative losses will be occurring with respect to the radius of the curvature in optical fibers, that too in macroscopic bending and microscopic bending. What is macroscopic bending? Now, you are having an optical fiber. Now, when you give it to children, they start bending that one. So that type of bending is called as a macroscopic bending. Now, once when you allow light to pass through such type of fibers, light will never pass perfectly, properly. Why? Because its bendings have already taken place. Due to that, loss is taking place. That type of bending, we call it as a macroscopic bending. Now, microscopic bending. Microscopic, very small changes in the optical fiber also, loss of signal will take place. That we call it as a microscopic bending. Okay, so this is about the types of optical fibers and losses which are taking place in the optical fibers. Now, as you all know, applications of optical fibers are many, and they are basically used in optical fibers in medical industry, in communication it plays a major role, and in defense purpose also, and then also in the broadcasting process it is used. These are some of the applications which I have just given you the names of them. That is, they are used in defense, in industry, in communication, and in broadcasting. Okay, next we have the last one. Last thing is, what is the block diagram of an optical communication system? That is nothing but how does an optical communication system works. Now, this is the block diagram. Before this one, an optical fiber communication system consists of 5 main components. First one is called as an analog, that is called as an encoder. First component is encoder. Second component is transmitter. 5 components it consists of. First one is encoder, second one is transmitter, third one is optical waveguide. Third component is optical waveguide. Fourth component is receiver. Fifth component is decoder. Now, what is the purpose of this each component? What is the major role of each of the component in the communication system? Now, whatever you are giving, for example, let us take 2 friends. They are talking on a phone. Now, I said, hello. Now, this hello cannot be recognized. It has to be converted into another signals. These are electrical signals. Now, the hello signal which you are giving is an electrical signal. This electrical signal has to be converted. That conversion process is done by encoder. Encoder will convert the electrical signals to binary signals because the computer can accept only zeros and ones. It cannot take hello. It takes only zeros and ones. So now the electrical pulse is converted to binary signal in form of zeros and ones by using the component encoder. That is the purpose of encoder. Next, that signal which is coming out in form of zeros and ones, that is given as an input to a transmitter. That is given as an input to a transmitter. Now, this transmitter also consists of three main components. Transmitter consists of three main components, that is voltage to current converter. We have to convert voltage into current by using this component. Then second component is LED, whether it is output is produced or not, that is 0 or 1, it is coming, that will be checked by the LED. Next, third one, source to fiber connector. Now the signal which is coming out, that has to be connected to the optical waveguide. So transmitter consists of three components, that is voltage to current converter, LED, next source to fiber connector. Next, from this one, the signal is coming out. Now, this signal is given as an input to optical waveguide. That means this is the process where light has to satisfy. Light in the sense is nothing but the signal has to satisfy the principle of total internal reflection. Now, the signal which is coming out given as an input to the optical waveguide. Now, the signal passes through the optical waveguide. If it satisfies the condition of angle of incidence is greater than critical angle, then automatically the light satisfies the principle of total internal reflection. Now, that signal which is satisfying total internal reflection is given as an input to the next component, the receiver. Now, receiver also consists of three main components. First component is the light detector. Here we'll be using two types of diodes. It is nothing but a diode, pin diode or photodiode we use, where we can detect the signal which is coming out from the optical waveguide is correct or not. That can be checked by using the pin diode. Next, from the pin diode, again we have to convert it into current to voltage converter, because here we are using in transmitter voltage to current converter. Now this current has to be converted to voltage, so that is present in the receiver. Now from the receiver, from this one current to voltage converter, we are giving it to an amplifier to check the signal whether it is properly coming or not. That amplification is done. Now from the amplifier, the result is given to the decoder, because the amplifier which is producing the light signal, it is coming out in form of zeros and ones. Now we cannot read zeros and ones. We know only hello. So that hello has to be, that zeros and ones has to be converted to hello. So that is connected by using the last component, that is the decoder. So decoder is a component which converts binary signals to electrical signals. These are the things which happens in all this communication system. You are just using a phone. You are saying hello. The other person is receiving hello. But this is what is happening inside an optical communication system. So this is one of the major application of an optical fiber. And then it is used in endoscopy. Optical fibers are majorly used in medical process. In endoscopic process, they use this optical fiber. They pass through an optical fiber. In that optical fiber, they send an solution through various parts. It gets spread and it will be recorded through the monitor. That is, through the TV, it will be recorded, where you can identify whether what are the defects present inside the body can be detected by using this endoscopic instrument. Okay, so this is about optical fibers topic. With this, I have completed lasers and optical fibers, which is 5th unit in applied physics prescribed from JNTU syllabus. So the textbooks which you need to follow are S.O. Pillai and Palani Swami, because they are designed with respect to in a simple manner where you can follow easily. So with this, I close my session. I have completed this chapter. So thank you.